Oh my gosh, microphone muted the whole time. Give me a moment. Okay. Strike that, reverse it, start over. Hello, good morning, welcome to here. I hope you're doing apparently better than I'm doing. Can you hear me now? Is it working? I see the little bars bouncing around. I need to remember to watch for that. Okay. Well, as I already said to nobody, this is possibly the toughest section. This is section 2 for our rational functions. So to get to the rational functions, we're going to first deal with the rational expressions, right? And then we'll turn them into functions next week. Yesterday we multiplied and divided them. So today we're going to deal with adding and subtracting them, which is literally the worst part. And it's not all that bad, okay? But if this is the worst, that means after we get over this bump, we'll be ready to go for the rest of it, and the rest of it will be easy, okay? So I want to start with a little reminder here. Rational expressions are just fancy fractions that we added, algebraic variables and other shenanigans into. So how do we add fractions? It's not as simple as the multiplying and dividing bit. We need to find something else first. What do we look for when we add fractions?
Common denominators?
Common denominators, right. We got to make these things in the bottom match. 3 and 5 are not the same. So we need to make them the same, which means we're going to apply to each of our fractions, multiply by a fancy form of 1, right? Something that is the same on the top and the bottom, such that this times that will give us some number, right? This times this will give us something, and this times this will give us the same something. So the first process, and in fact the first exercise that you will go through on the front worksheet, is to practice finding the least common multiple of, in this case, the polynomials that will appear in our rationals. Right? Because the least common multiple is, as it implies, the smallest possible common denominator that will work for us. So in this case, since we have a 3 and a 5, the LCM is just 3 times 5, or 15. So we're looking to create 15 in the denominator on both sides. So to make 5 into 15, I multiply by 3, which means I also must multiply the 4 by 3. Right? And so now this bit, our order of operations still applies. I'm going to do this multiplication before any of the addition happens. So we can real quick usually I like to just cross them out and be like, oh, it's 15 now. And so the 4, cross that out, becomes, times 3 is 12. 3 times 5 is 15. And 2 times 5 is 10. So now we can add across, and we'll have some number of 15ths. 10 plus 12 is 22. And 22 and 15 do not share any common factors, so that is my as reduced as it gets final answer. Right? We all remember how this works. So then how then do we apply that to rational expressions? Same deal. I first want to find the LCM of the denominators to create my common denominator. And always check first, is one of the denominators a possible common denominator? Can I simply turn one of them into the other? So that's the best bit. That's the easiest bit. Can we do that here? Is there something we can multiply x squared y by to get just y? Or is there something we can multiply y by to get x squared y? I think there is. I think there is, right? If we multiply this guy by x squared times y, it'll be x squared y. So I need x squared times x squared, right? Which means up top I have x cubed. I don't have to do anything to the other side. It's fine as it is. We'll just leave it. And the denominator is just going to be the x squared y. And up top, I'm going to have 2 minus x cubed. And, well, I mean, it's funny looking, but that's the answer. That's it. There's nothing else I can do to that. Acceptable so far? Okay. How about this one? Let's try this on for size. Is there a way I can make the denominators look the same? Ooh, maybe. I mean, this is plus 4, this is minus something, I don't know. Hold on, what is this? This is a whole quadratic down here, right? First thing, always, when in doubt, factor it out. So I don't like the looks of this. Instead, I would much rather have it be a times a plus or minus something, a plus or minus something else. I'm looking for, let's see, in this case, I need factors of negative 20 that will add to negative 1. Factors of 20 include 5 and 4. Ooh, those are apart by 1. So it's just a matter of getting the signs right. So if I want to get negative 1, so minus 5 plus 4 times 20, 1 negative, yep, negative 5 plus positive 4. Yes, this will work. Okay, and ooh, look at that. Providence. We have a matching thing. So I only need to multiply this by the other factor. A minus 5 over a minus 5. So our denominator will be a minus 5 times a plus 4. I'll just leave it in factored form for now. And this will be a times a minus 5 plus another a. Okay, and I think we might be able to simplify that out, right? This will distribute, and then we can maybe get a negative numbers of a's and cancel out some of that. So let's go ahead and do that. A plus an a squared minus 5a. And is that, just checking, that's not like the same thing that's down here? No. Okay, that'd be too easy. It would be still over our denominator. Don't leave that. But now we get a squared minus 4a, right? So far. And can we factor the result out any further? I can factor out an a. Oh, so close, so close. A minus 5, a plus 4. If only it turned to be plus 4. If I factored out a negative a, well, that wouldn't work because this would be the squared. So, well, you can't just change a minus 4 to a plus 4, unfortunately. So it doesn't reduce any further. That's going to be my final answer. Any questions on how I went through that? No? Okay, then, now that you've gotten to see examples live in class, it is time for the thing we totally forgot to do yesterday, the quizzes. All right, so I've got 14 questions for you here. We'll start with these practice, and then when you are done with the quizzes, you can move on to the rest of this worksheet, okay, which has a few additional examples for you there. And this. Here we go. Please go to joinmyquiz.com. Enter the code 494331. 494331. And let's see how much you can do already, okay, before the extensive practice. Up, that's 3. Four. All right. Well, those in, go ahead and get started. Code is still there. I'm waiting for, who am I waiting for? One more. Blanca, we're still waiting for you to connect. But otherwise, yes, carry on through these. When you are finished, go ahead and get started on tonight's worksheet. And that sheet, as specified on Classroom, will be the homework. That's all I've got for you. We'll wrap up the